Okay. So are we okay with cosine of pi over 12?
Yes.
That's it. Moving on to part C. If you're okay with me moving on to part C.
Yes.
Okay. Sine x, sine 2x, minus cosine x, cosine 2x.
Change the order.
So what does this resemble?
Nothing. Oh, it's cosine is backwards.
Okay, yeah, it's kind of cosine, but it's backwards, isn't it?
So would it be minus cosine? Negative cosine?
So there's a couple of, if we reverse this, because up in the identities, what's supposed to come first? Cosine. So if I reverse this and I say cosine x, cosine 2x, and then sine x, sine 2x. This is what? It's a negative cosine and a positive sine.
Well, they're opposite, like they're supposed to be.
Now, does my identity up above allow for a negative cosine cosine? No, cosine cosine always has to be positive. So, okay, small trick here. Factor out a negative. If I factor out a negative cosine x cosine 2x just becomes positive cosine x cosine 2x plus sine x sine 2x becomes minus sine x sine 2x. I'm running out of room. I didn't set this up right. Okay. So we have a negative out front, yes? I'm going to put this right below here. And then, what do you know about cosine, cosine minus sine, sine? This is going to be which type of identity? This is cosine. And what are my pieces? X and 2x. Are my x and 2x being added or subtracted? Added because the cosine identity uses the opposite sign. So this is going to be plus. Now notice, what did I just carry down out front? The negative. So, okay, basic middle school math, what is x plus 2x? Right? 1x plus 2x is 3x. And so, my final answer, the negative of cosine of 3x is what we're going to put there. What?
I was just kind of thinking that there was like a season of other but it's not in the
If the negative was in parentheses, we could think about how does that change, but meh. We're not going that direction today. Okay. So officially the directions in this section say write each of the following expressions as the sine or cosine of an angle. But D is obviously a tangent. Can it be any more obvious, right?
I don't know.
I guess it could be. Okay. So
I really would require that.
this is a tangent. What are my x and y values? 22 and 23. So we're going to use 22 degrees and 23 degrees. Here's the hardest part. Is it a plus sign or a minus sign?
I know.
Wait, let me see.
Because the path is a plus sign.
Okay, so notice it's a plus and then a minus. If I go back up to the rules up here, it's plus minus in here and plus minus on top. So that means you're using the same sign as what's on top, minus plus on bottom. So we're using the opposite sign of what's on bottom.
Okay.
So basically you're always using the top sign and the opposite, the bottom one should be the opposite. So what was my sign on top here? Plus.
Do I have to put it over something?
Nope.
Okay.
Tangent of 22 degrees plus 23 degrees is?
No, it's 55. 22 and 33? 23. I went 33. That's why I was like 34.
So do we leave it there or leave it?
I left it as tangent at 45 degrees. I mean, we could say 1. But for the purposes of what we're doing, I'm really looking for tangent at 45. That's really my purposes. And that is the purposes you'll see in homework.
Does it matter if I skip all of these?
Yeah, that one's pretty nice. Well, that
Because
and
I voted on
Pretty
pretty
easy so far.
I could see you knowing that. I mean, I could see that. Okay. Example 3. I don't know. A slightly teensy bit more difficult version of example 2's, but it's not bad. So,
simplifying is just getting it into this one.
I mean, this is kind of a combo of what we did in example 1 and what we did in example 3. Or example 2, I mean. Example 1 and example 2 combo here. Now, sine of x plus pi. Okay, obviously the point of today's lesson is using these identities, right? So, kind of like up in example 1, we need to write it out. How do we write out a sine?
Well, it's x and y, so we have x and y.
Okay, so think of this as the form of sine of x plus sine plus y, right? So x is x, which is helpful, and y is going to be pi. Okay, so write this out like what we would have done on example 1. When you look at the sine identity, it says to do what? Sine x, sine y? Excuse me. Sine x, cosine y. So it's going to be, in this case, sine x, cosine pi. Okay, do I use a plus or minus sign?
Plus.
With the sine identity, use the same sign, so plus. And now it's going to be
Cosine x sine pi.
cosine x, and it's sine of y, which in this case is sine of pi. Okay. Sine x and cosine x, we're stuck. X is a variable, we can't do anything with it. However, cosine of pi, I guess I said just get out your chart, but your unit circle is probably helpful here. Because we need to do some simplifying here. So sine of x, and then cosine of pi. He says -1. You guys agree?
Yes,
Probably. Probably is not a good answer.
I don't have my unit circle. I don't know.
Okay, cosine of pi. In order to pair, remember it is cosine sine. So what is the cosine of pi? -1. Plus cosine x is cosine x. Sine of pi.
0.
Cosine sine, 0.
It makes the whole second part 0, right?
0 times anything is 0, so cosine times 0 is 0 and gone.
So it's
Sine x times -1, negative sine x.
I like this unit.
me too.
It's very kind.
Okay, let's try B. Cosine of x plus 3 pi over 2. Again, realizing your parentheses are your x and y values. How does a cosine identity work?
It needs to be opposite. It's cosine, cosine.
Cosine, cosine. So I'm going to start with cosine of x times cosine of 3 pi over 2. The plus or minus sign is opposite. So since this was plus, we're going to use minus. And then it's sine sine. So sine x sine of 3 pi over 2. Like the last problem, we're stuck with the x's, right? Cosine x, cosine of 3 pi over 2.
The cosine of 3 pi over 2 is
3 pi over 2, cosine is 0, and while we're here, the sign is going to be negative 1. So cosine, sine. So cosine of 3 pi over 2 is 0 minus sine x times sine of 3 pi over 2, which is negative 1. Cosine of 0, or cosine times 0 is 0, minus sine x times negative 1,
going to be
positive sine x.
Is it pi over 9?
Pi over 4,
Oh.
I think. Yeah. Okay. Last official problem. Tangent of theta minus pi over 4. Again, x and y, right? I don't know that you guys really need me write the x and y in, but just in case. Okay, you ready for the fun stuff? It's a fraction, but it's not that bad. Okay, so the tangent. On top is tangent x, which is tangent theta. Am I going to use plus or minus?
minus.
We use the same sign on top. So it's going to be minus tangent of pi over 4 over 1 plus or minus. This is the opposite sign, so we use plus. Tangent theta, tangent pi over 4. What's the one thing I can replace?
The tangent of
What's tangent of pi over 4? 1. According to my chart, tangent of pi over 4 is 1. So, I have tangent of theta minus 1 over 1 plus tangent theta times 1. Which, what can I clean up here?
the bottom.
Multiplying by 1 on the bottom is about all you can do. So really, on top, it's tangent theta minus 1 in the denominator. 1 plus tangent theta. I guess in my previous problem I reversed and put tangent theta plus 1. I guess I'm off the screen here so you can't even see.
I leave it like that or do I have it?
You can leave it either way. I don't care in the denominator whether you put 1 plus tangent theta or tangent theta plus 1. I only care when it comes to a subtraction and you reverse that. Okay, so officially, that's all of the notes. And as I look at homework, okay, 1 through 10, you're doing a lot like what you did in example 1. The only slight issue is that a good portion of them are in radians. So I want to show you one in radians. So actually, I think I'm just going to pick one from the homework and go ahead and talk about it. 11 through 15, you're doing what we did in example 2. Those were the piece of cake problems, right? Where do I have you going? Okay. 16 16 through 22 is really a continuation of 11 through 15, but some of them you might have to treat like the bottom section. So really, 11 through 22, the second half of the homework is a combination of examples 2 and 3. Okay? Just kind of depends on what they give you.
Can I take a picture of the answer book? Because I don't know if I have it at home.
Yeah, I can give you a brand new one if you want.
Does it have the numbers written on it? Oh, it does.
I don't know. What question are you asking there?
So, you look at
Okay. I would go ahead and get a piece of, I figured I might as well just give you a help with a homework problem, right?
Yeah, use that.
If you take a glance in the homework, and I guess half of you probably don't even have the book with you, but what you will notice, so 1, 2, 3, 4, you're doing exactly what I did on example 1. It's in degrees, piece of cake, right? 5 through 10, you have to use radians. And if you happen to be looking in the book, all of those denominators are in terms of twelfths. Does my chart over there have twelfths on it? No, we have pi over 6, pi over 4, pi over 3. But what is very nice about pi over 6, pi over 4, and pi over 3? Can they all become twelfths? I think I might flip this over and do this on the back side. Come on, seriously?
What number is it?
I haven't picked a number yet. Here's the first thing I would suggest. Pi over 6, pi over 4, and pi over 3. What are each of these in terms of twelfths?
3 pi.
So pi over 6, when we make it twelfths, you're multiplying by 2, and this is 2 pi over 12, yes? Pi over 4, we're multiplying by 3, and so that's equivalent to 3 pi over 12. Pi over 3, multiplying by 4, it's 4 pi over 12. And so the reason I give you those is because, let's see, we did a cosine on example 1, didn't we? So let's do number 6. And number 6, this is from your homework tonight, is the sine of 7 pi over 12. And you're being asked to find the exact value. Use the sum or difference identity to find the exact value. Now, do you see why it's helpful to have those twelfths?
Yeah.
Because I'm going to rewrite this.
Oh, can you do 4 pi over 12 plus 3 pi over 12?
Yeah. 7 pi over 12, I basically need to use pi over 6, pi over 4, and pi over 3. But because it's 7 pi over 12, you have to think in terms of twelfths. And so what adds up to be 7 pi over 12?
4 pi and 3 pi.
Okay, so 4 pi over 12 plus 3 pi over 12.
Is it 7 pi over 12?
Uh-huh. The original problem is 7 pi over 12. Sorry, that pen was not cooperating, so I'm changing pens here. So now, how does your sign identity read? In other words, what are x and y? 4 pi over 12 and 3 pi over 12. Now, it might be helpful at this point to think, what is 4 pi over 12? That's really what? Pi over 3. Plus, what's 3 pi over 12? Pi over 4. So really what you're going to be doing is sine of pi over 3 plus pi over 4 And why did I change back to pi over 3 and pi over 4?
They're all-
They're on our chart, right? Which technically 4 pi over 12 and 3 pi over 12 are on the chart, but that's not how you see it, is it? So, okay, how's the sign identity read? Sine of x, so sine of pi over 3 times cosine y, so cosine pi over 4. In the sign identity, do I use the same sign or opposite sign? Same sign. So it was sine x, cosine y, and now it's going to be cosine x, so cosine of pi over 3, sine of y, so sine of pi over 4.
And then we're supposed to do the unit circle, right?
What is the sine of pi over 3? According to our chart, according to the unit circle, square root of 3 over 2. What is the cosine of pi over 4? I'm going to go square root of 2 over 2. Not disagreeing with you, but
This makes it clean.
it just makes it cleaner in the end, yeah. Cosine of pi over 3? 1/2. Sine of pi over 4?
2 pi, or square root of 2 over 2.
Square root of 2 over 2. Clean it up. Square root of 3 times square root of 2 over 2 times 2. Square root of 6 over 4 plus square root of 2 over 4. If I put it together,
Square root of 6 plus square root of 2 over 4.
square root of 6 plus square root of 2 all over 4. You now have one less problem to do in homework. If you happen to remember later that you have this written down. Maybe you already did it on your homework paper, so it's all good, but
I do.
yeah. Now, that will help with a decent amount of them. There's an 11 pi over 12 that we'll have to talk about tomorrow.
So were we just using combinations of pi over 3, pi over 4, and pi over 6?
For the most part, yes, you're using combinations of these three right here. There's like an 11 pi over 12, which notice we can't get that using first quadrant angles, so we actually have to move to second quadrant angles there. Which we can talk about that example tomorrow.
Okay, so I can like not do that one.
Well, I would still try it and think about it. Okay, guys. 1 through 22 for tomorrow. It is due tomorrow. Bring your questions.